party people. Got a little 6-6 action happening for you today, and it's a pretty quick video. Inequalities, just like last section, but now we're talking about two triangles, not just one. If two sides of one triangle are congruent to two sides of another, what can you say about the third sides of the triangle? Let's see what's up. All right, introduce you to the first couple theorems. We're talking about the hinge theorem and the converse of the hinge theorem. So we're going to be able to compare some things here in triangles. And again, it's inequalities, so we're looking at greater thans and less thans. All right, so the hinge theorem. If two sides of one triangle are congruent to two sides of another, and the included angle of the first one is larger than the included angle of the second one, then the included angle of the second, then the third side of the first is longer than the third side of the second. So that and that. So just think about this logically, guys. They call it the hinge theorem because just like a door, if you have two sides, as it hinges, open and shut, if you know this length and this length are the same in the two triangles, then we can compare however much we open or shut the door, that third side is going to be affected. Just think about it swinging open and swinging shut, because if you don't change those two things, then the angle is going to dictate how big that side across from it is going to be. All right, so we would know in this theorem example that Wx would have to be greater than St because 88 is bigger than 35. The converse is also true. You can work it backwards. If you know two sides of one triangle are matched up with two sides of another, just like this, if you know the third side, of each, you can compare it backwards to determine which angle would be greater. Since 12 is bigger than 9 in this example, C would be greater than F, because the angle that swings open at C is making a 12. The angle that swings open at F is only making a 9. So pretty logical with the hinge theorem and its converse. Now let's see some examples here to make some greater sense of the matter. Example 1. Given that, so we got two triangles here, and you know the reflexive property is going to happen a lot, so PS. Given that ST is congruent to PR, so that's that slash and that slash, how does the angle at PST, so we are comparing this angle at PST, how's that compared to SPR? So you're comparing those two angles, and again, this is the inequalities in this section because we're talking about greater thans and less thans. So we can't tell exactly what those angles are, but we can compare them to each other. And the first one, PST, is pointing across to a 24. So it's hinging open and creating 24 inches. As opposed to angle SPR, it is swinging open and only creating 23 inches. So therefore, the angle at PST, the measure of angle PST, would have to be greater than the measure of angle SPR. 2 more minutes. All right, so that's the hinge theorem using the converse of it. All right, second example, and again, it comes down to we are using the reflexive property. We know that JK is the same as LK, so now we can compare JM and LM based on the fact that we know 64 and 61. since 64 is greater than 61, JM is going to be greater than LM. And whoop, there it is. It's that easy. Can I get some love from the audience? Yeah, we got a live studio audience for this video, party people. All right. 2 minutes, that's it. You can hang out. You can stay if you want. You can hang outside for a minute. I'm about done.
I'll enjoy the show.
All right. Monitoring progress. Pause the video here and see what you can come up with these two. All right, welcome back. So in the first one, we got PR being equal to PS, so that's given. And we know that we can always go reflexive there in the middle. The measure of angle Q to P to R, so that's, let's switch colors here for you. QPR is greater than QPS, so they're telling us something about those two angles right there. Well, if QPR is greater, then the side that QPR opens up to will have to be greater than the side that QPS opens up to. So therefore, we've got QR, this is for number one, QR being greater than QS. All right, and the second one. In the second example, or monitoring progress question, now we're taking a look at, let's see, if RQ is less than SQ. So if you want to throw numbers in now, you can do that. So like, just to make it easier for yourself. Which would be larger? Would it be the angle that is creating QR or the angle that is creating QS? And of course, since SQ is larger, trace it back. The angle that creates it would be greater. So the measure of angle QPS would be greater than the measure of angle QPR. All right, so there's our monitoring progress questions. Our extra example, let's check out what we got right here. We've got, given that AB is congruent to DE, so that's marked up. BC congruent to EC. And we know some angles. We know we have a 48 over here, we have a 47 here. How does AC compare to DC? Well, the 48 is greater than the 47, so AC is going to be greater than DC. You guys miss this stuff, don't you? Yeah, calculus coming at you, smacked y'all in the face. All right, and this one. We got 27. The angle that is creating 27 is going to be greater than the angle that creates 26. So the measure of angle Q will be greater than the measure of angle A. All right, so again, we can't really tell exactly what those angle measures are, but we can compare them to each other. So there you go. In our final example here today, we got a little real life situation happening. Two groups of bikers leave the same camp heading in opposite directions. So here's camp. And let's see, each group travels 2 miles, then changes direction and travels 1.2 miles. So each group goes, they're in opposite directions. So I got 2 miles going that way. Let me switch colors. So then I got 2 miles going this way, opposite directions. Then they go 1.2. So I've got 1.2 and 1.2. So now here's the only really tricky thing from the lesson. Watch how this works. Group A starts due east and then turns 45 degrees north. So think about it like this. Here's the path they were heading. They are turning 45 degrees north. So that is a 45 degree angle, which creates a 135, which would be right next to it. So subtract it off of 180 to get the angle inside your triangle. The second group, they were traveling west, and then they turned 30 degrees south. And again, it's the 30 degrees south in that direction that would leave you with a 150 inside of your triangle. Which group is further from camp? So they're essentially asking you which distance is longer, because they want to know, here's where they ended up, how far back to camp is it? Here's where group A ended up, how far back to camp is it? And so think about it like this. When you start to turn, the greater that number is of your turn, so if it was like 180, you'd be heading all the way back to where you were starting from. So a 45-degree turn is going to have you closer to camp than a 30-degree turn. And essentially that's what this is depicting. So the 150 you're left with inside the triangle is going to create a greater third side than the 135 is pointing to. So the group that is further from camp is going to be group B. All right, guys, that's a wrap on 6-6. Peace!